All right, guys, so back here, so now we're C. All right, so this one's going to be a little longer because of C is pretty lengthy. So first off, degree. Degree here would be 5, so we show it again, 5 actual zeros at the very end. Okay. Step 2. Oh, so signs, right? So let's see. That's 1 sign change, 2 sign changes, 3 sign changes, 4 sign changes. Wow, 5 sign changes total, right? So this is going to be a lengthy one. So before we get any further, just do the other one as well. So f of negative x would look like this, right? So odd means flip. Even is stays the same. So this one flips. Even stays the same. Odd flips. And that stays the same. So notice this one has no sign changes. They're all negative, which is kind of great news, right, when it comes to it. Now, in that case, let's go back to the positive. So we had a total of 5 sign changes here. So this is when this Descartes' rule sign gets a little funky itself, okay? So here are the scenarios we have. We can have a total of 5 positives, or, okay, what's an even number between 1 and 5? And hopefully you say 2, right? Okay, so what's 5 minus 2? 3. So we have also 3 positives. Okay. What's another positive 0 between 1 and 5? 4, correct? So what's 5 minus 4? 1. So these are the possible scenarios we can have. We can have all of them positive, 3 of them positive, or 1 of them positive. Okay. And the good thing is we're guaranteed 0 negative zeros because there were no sign changes there, okay? Which is yay, right? So that means they're all positives no matter what. So if we're not in this case, therefore, in these 2 cases, we're going to have some complex roots. Hence the reason why it's not always going to be one or the other, okay? All right, now let's go on to number 3. All right, so number 3, our a sub n, this one's 1, right, for sure. Make sure, yeah, that's 1 for sure, okay? All right, so now a sub naught is negative 36, which is a pretty big number, right? All right, so let's list all the factors, plus or minus 1. All right, 36 is a lengthy one, so like I said, right? So we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. 5 doesn't go into it, 6 goes into it. 7, 8, 9 goes into it. 10, 11, 12 goes into it. And I think the last one goes into it is 18. And then finally, also the 36 as well, right? So there are a lot here. Now, the good thing is, right, it's all of the numbers divided by 1. So essentially, it's this entire list, okay? Now, you may be thinking that is a lot because technically it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times, so 9 times 2, 18 possible, scenarios where I literally have to guess, right, at step 4. That's a lot of guessing. However, right, this is the reason why Descartes' rule sign is so powerful. Remember, we're guaranteed all of them to be positive. We're guaranteed none of them to be negative. So essentially, instead of the plus and minuses, we'll only have to check all of the positives. Because again, we're guaranteed not to have any negative zeros. So there's no really need to check them all because they're not going to be working. So that cuts our search literally in half. That's the power of Descartes' rule of sign, which makes it so much nicer to deal with. Okay? Kind of nice, right, when it comes to it. Let's see if this focuses better. There we go. All right, now at this point, unfortunately, now it's a guessing game, right? But again, 9 is far better than 18 to deal with, right? So I'm pretty sure you guys all started with 1, which, usually it's the easy one to deal with. So if we plug in 1 to the function, and believe it or not, it actually works out. 1 is actually a factor. So if you plug in f of 1 in the function, we literally get 0, which is the best part, right? That's what we want to happen. Yay. So therefore, x minus 1 is a factor of that. All right, so doing synthetic division, right, breaking this down, we have 1, negative 7, 19, negative 37, 60, and negative 36. Okay. All right, bring down the first one. That's 1, negative 6, negative 6, positive 13, 13, negative 24, yes, 24, 36, 36, 0, right? Okay, so since we started with 5, this now becomes 4, so we have x to the 4th minus 6x to the 3rd plus 13x squared minus 24x plus 36, right? Break them down. Okay, so again, from here, now we break it down again. So again, right, it comes a guessing game, but the good thing is one works, then now we got to figure out the other ones. Yay, right? But again, right, hopefully you guys have a little practice and try this out, and we're going to try 3. So hopefully 3 works. Okay, so if you plug in 3 into the function, you should get 0 out as well. Okay, that's also when that works. Okay, so I'm running out of space here, so I'm going to put it on this next page here, right? So 3 works. So therefore, we have 2 factors, x minus 1 and x minus 3, right? Because it's the opposite sign of these, so C works, right? So again, if we do synthetic division to break it down, using our C being 3, and using our new polynomial down here, okay? So again, it's going to be 1, negative 6, 13, negative 24, and then 36. Okay. All right, breaking this down, this gives us 1, 3, negative 3, negative 9. That should give us 4, 12, negative 12, negative 36, and 0. Okay. So we started with 4, so this is now a cubed. Like that. Now, getting it closer, right? It's cubed. We want square to make it far easier for ourselves, but back to the drawing board, right? So we know 1 worked, 3 worked, so cross that off, and you could try the rest. But hopefully you guys did try some of them and notice a lot of them didn't work. And you may be going on this video saying, okay, which ones actually worked? Well, now it's time to throw a wrench in you guys' portions. Let's try 3 again. Yes, which means we can have multiple of the same number. How fun, right? So if you plug in 3 into this, you should get 0 as well. Yay, right? Which means we have a double root. We have x minus 3 and x minus 3. So if we do 3 again into this portion, we have this now. So started with cube, so this is now x squared, 0x's plus 4. Ah, perfect. Quadratic, right? We know how to factor that. Now, the problem is, right, this actually never equals 0. It's imaginary. Ooh, imaginary, right? So we have to leave it just like that. So essentially, notice we had 3 positives. So we were actually in this scenario. Okay, these are 3 imaginary roots itself. Okay, haha, interesting, huh? So therefore, our actual polynomial broken down is going to be x minus 1, x minus 3 squared, and also x squared plus 4. And if you're wondering, well, why is it, squared there, right? Notice, right? Since if this is broken down, I can now ask you to graph this, right? That was on the last test, right? Using the powers and, and the evens or odds, right? If it's crossing or turning points, right, respectively, right? The whole point is, right, if I give you this now, you'll be able to graph that, pretty lengthy, right? No, it's a long process, but that's the main goal of how to do this, is, right, given out any polynomial in the world, you can now graph it using all of these rules itself. Okay? All right, so that is C. Now let's finally go D. So D will be a little quicker because it's actually a little faster. Okay, so step 1, it's degree 4. Step 2, sign changes. 1, 2. So we have either 2 positive or 0 positive. Now we do the same thing for negative f of x. That's even, so it doesn't change. This is odd, so it changes. This is even, doesn't change. This is odd, changes. Okay. So none here. That's a 1, 2. So we have the same scenario as above, right? So we have 2 negative or 0 negative. Okay. So same scenario we had for part B. Okay. Right? And next step, step 3, we have a sub n is the same as a sub naught is 2. So plus or minus 1, plus or minus 2, plus or minus 1, plus or minus 2. Okay. All right, so therefore our zeros are going to be plus or minus 1, plus or minus 2, right? All these divided by that, and then all of those divided by 2. So plus or minus 1/2, and 2 over 2 is 1. So therefore, we have a total of 6 to choose from. Not bad, right? Not too bad to deal with there. Okay. So pretty sure you guys always choose 1 or negative 1. So let's choose 1. So if you plug in 1 to the function, just going to quickly do this. This could be 2, negative 1, negative 5, 2, and then 2, right? If you just plug in positive 1. And that actually gives you 0, which is the best part, right? So yay. That's one of our answers. So therefore, we know x minus 1 is a factor. Okay. All right, so now doing synthetic division here, to break this polynomial down, gives us 2, negative 1, negative 5, 2, and 2. That's 2. This is a positive 1. That's 1, negative 4, negative 4, negative 2, negative 2, 0. Okay. All right. So therefore, again, we started with 4. So now this is 2x to the third plus x squared minus 4x minus 2. Okay. All right. So now rinse and repeat, right? So we got 1 out of the way, so that works. So we only have 5 other choices to choose from. Again, I don't know. This already is about 13 minutes long, so I'm gonna just guess on one of them. Let's say I don't know, 2. Let's try 2 real quick. That fraction is pretty nasty, right? No one wants to deal with fractions. So let's plug in 2 into the function. So again, I'm just going to quickly use calculator, make it a little faster. 2 to the 4th times 2 is 32. Minus 2 to the 3rd is 8. Minus 5 times 4 is 20. Plus 4 plus 2. And this gives us a grand total of 10. Which is not 0, right? So 2 doesn't work, right? 1 worked, 2 doesn't work. So keep going from there, right? So give you guys a hint. Negative 1/2 actually does work. So C equaling negative 1/2 does actually work out. Okay. So since I've given you guys that, right, so we'll just go from there. So we just rewrite what we have here. Start there. Where's it? Here. So C works. So negative 1/2 is our C. So our numbers are going to be 2, 1, negative 1, and negative 2, right, in our synthetic division coming from here. Okay. All right, bring this down. So 2. This is negative 1, That's 0. That's 0. Negative 4. Half of that is positive 2. And there we go. Right, that works for there. So give you a little quick recap. So from the 1, we have x minus 1. And from the negative half, it says positive, right? X plus 1/2. And now this factor, we have starting from 3. This is now a 2. So this is x, or so 2x squared. 0x is minus 4. Okay. All right, so now we can factor this, right? So factoring this, we can just factor a 2 out. Okay. Now again, if you're really interested, you can leave it like this, but if you really want the factors, again, simplified, notice this is a difference of squares. This is 2 minus square root of 2, and this is 2 plus square root of 2. Okay. Again, if you really want, but you can leave it like that if you want, it gives you the factors there. But breaking down completely, right, this polynomial now is x minus 1, x plus 1/2, and then this one too, so I'll put the 2 in front, and then this is x squared minus 2. Or if you want, implied into here. So 1, 2, 3, 4, right? There's our 4, because it's degree 4, and voila. All right, guys, so that ends the lesson for 4.5, Zero is a polynomial. Make sure you email me or, go on the discussions if you have any questions when it comes to it. This is a pretty hefty section, so, it's not as clear cut as the other ones itself.